Hello, welcome back to 5G QS course, part 2. I am Puriya Ali and thank you for your positive feedbacks in LinkedIn for part 1. And here I add the first part link here. You may see the link online here on YouTube. And if you are looking at this video offline, you can search on YouTube for the first section here. Qos in 5G YouTube. You may see me in the first page on Google, Qos in 5G YouTube. Okay, I'm not going to let it play. You may find more information about me on palinejad.ir, or you may contact me on LinkedIn in case of any questions. My LinkedIn account is linkedin.com/in/puriya-alinejad. So let's start the remaining sections. In previous video, I discussed section 4 and section 5 on QoS architecture and QoS flow characteristics. And now we are going to take a look at QoS flow provisioning and mapping and enforcement. At first, here we have a dictionary to check the terminology. And before we start this chapter, we need to be familiar with some terms again. These terms are related mostly to SMF, Session Management Function in Core Network. The first one is Service Data Flow Filter. We have seen this term in Chapter 2 where SDFs are classified from IP flows. Here it is defined as a set of packet flow header parameter values used to identify one or more of the packet flows in the UPF. And these packet flows, as you know in UPF, are IP flows. Maybe it's a little bit hard to understand these terms now, but at the next slides you will better understand the contents. So trust me and just listen to these definitions, no need to go into the details now. Next one is Service Data Flow Identifier. It is a scalar that is unique for SDF. And it's unique for a PDU session. So it's just a numbering for each SDF filter. The next one is Service Data Flow Template. It is the set of service data flow filters in a PCC rule. So templates are filters in PCC function. Easy. The next one is Service Data Flow. We have Service Data Flow Template here, Service Data Flow Template. And I put Service Data Flow here after that because Service Data Flow Template is used to define Service Data Flow itself. Let's read the definition. It is an aggregated set of packet flows carried through the UPF that matches a Service Data Flow Template. So everything that matches the template is a SDF. Here, note that SDF and SDF filter terms are just showing a set of aggregated packets, while SDF template is actually used to do something practical on packets. I mean, template is used to filter IP flows by using SDF filters to SDF flows, and you'll get to know them better in next slides when we use them in examples. The next one is binding. Binding is attaching SDFs to Qos flow. It is binding. A SDF is bounded to a specific Qos flow by SMF and UPF. And the next one is binding mechanism. Binding mechanism means all methods to do and undo binding, creating, modifying, and deleting these flows. The next one is authorized QoS. Authorized QoS is the maximum QoS that is authorized for a service QoS flow, service data flow. And you can read the definitions again if it's vague for you and unclear for you. And in next slides we will see them in the definitions, and then these terms will be clear for you. Next, go to next slide. In this slide, we see the SMF responsibilities on QoS. The SMF interacts with the UPF, with RAN and UE to achieve appropriate treatment of the user plane traffic. The SMF is responsible for the enforcement of the policy decisions related to this service data flow detection, authorized QoS, and this authorized QoS definition. You know now, it's defined in the previous slide. And the next one is charging, gating, traffic usage reporting, packet routing and forwarding, and traffic steering. So the SMF controls the policy and charging enforcement, and this includes binding of service data flows to QoS flows, and also it's responsible to interaction with the CHF charging function. Now, in this slide, we check SMF function QoS enforcement. The question is, what happens during QoS enforcement? And the answer is, at first, detection of user traffic or the IP flows is performed, and after that, after detection of IP flows, the Qos rules are applied to each of the detected service data flows. And it is the task of SMF to enforce the policy control, and SMF gets the rules from PCF. And these rules can be enforced in two different ways. The first one is by gate enforcement. In gate enforcement, the SMF should instruct the UPF to allow a service data flow. This means implementing policy control on UPF flows only if the gate is open. The second way is Qos enforcement. In Qos enforcement, we have again three scenarios. The first one is based on 5QI. In this case, the SMF gets 5QI, and based on this 5QI, it enforces corresponding Qos characteristics. So SMF knows a table to translate 5QI to 5G Qos characteristics. Second one is PCC rule based. Maybe PCC have some optional configured rules. So SMF should instruct the UPF to enforce the authorized QoS of a SDF according to its active PCC rule. For example, to enforce the SCP marking. The third one is based on QoS flow itself. When we have a set of Qos flows, I mean several SDFs, several service data flows concatenated together in a flow, and we want to enforce a policy on them, we need to ensure that the resources allocated to them is authorized and they don't consume more resource than they are allowed to. So we have an authorized resources defined in PCF, and some services have, for example, authorized resources A, and another services may have some another authorized resources defined in PCF. And different service data flows have different authorized resources, like the reserved GFBR and allocated MFBR for the QoS flow. And in this case, we need to assure that the service data flows do not exceed these authorized resources definition, which is defined in PCF. Now, let's see how this signaling are down to do the mapping. The SMF performs the binding of SDFs to QoS flows based on the QoS and the service requirements. And the SMF do these tasks by these 5 options. The first one is assigns, the SMF assigns the QFI for a new QoS flow. So it's the task of SMF to assign QFI for a new QoS flow. The SMF drives is Qos Profile. So based on the QFI, SMF drives is Qos Profile. The next one is SMF have the corresponding UPF instructions and sends it to UPF. For example, SMF can get the instruction from PCF and send them to UPF. Then UPF applies them on the service data flows, SDFs. SMF gets Qos rules from the PCC rules, and also other information provided by PCF, for example, some optional configurations. We will see more details in next slide. This figure provides a high-level description of the involved entities and nodes and related QoS communications in the control plane. Let me choose the laser point. Okay, here we have numbering, number 1, number 2, till number 5. Okay, and now we are going to follow these numberings and describe the tasks that are done during these signalings. At first, here, number 1, typically a specific QoS is enabled by the subscription in UDM, and it includes some special default QoS and also maybe application function request from PCF that I need a special QoS. So the UE may request for the QoS flow from the application function or by NAS signaling from SMF. So here we have 2 ways, through application function or through NAS signaling. The UE asks for a special QoS. Then at step 2, here we have one number 2 here, one number 2 here is bidirectional, and one number 2 here. During this step 2, at first let's see what happens in UDM. We have session AMBR parameter stored in UDM. However, session AMBR can be modified by PCF, and it is sent to SMF over N7 interface, and then the UPF will enforce the session AMBR received from this SMF. We don't have UPF here because it's control plane, but Anyway, it gets it from SMF. When a PDU session is established, this SMF receives session management subscription data from UDM. And this includes the default Qos values, and this SMF may also change these based on local configuration or interaction with PCF. The resulting values are used for Qos flow, and as a result of a PDU session establishment, the UE gets a default Qos rule. Here we have this number 2. UE will get the default Qos rule and optionally additional Qos rules and Qos flow descriptions. The UE also gets session AMBR that the UE uses for applying uplink rate limitation for the non-GBR Qos flows. Then in step 3 here, Qos rules are sent to the UE. And as you know, we described it in previous chapters. Qos rule contains, for example, the QFI, a packet filter set, the precedence value, and here the UE gets the Qos rules per PDU session to decide how mark and send the uplink data packets. Also here, UE will get the information for Qos binding mechanism, for modifying or deleting an existing bind to a Qos flow. And also it can get an EPS bearer identity, and in case we have 5G Qos flow mapped to EPS bearers in 4G, we can use this EBI. Then in the arrow number 4 to the G node B to access node, the SMF tells the G node B to enable the Qos differentiation. And here SMF provides Qos profiles. Here you see 5G access node gets Qos profiles. So here we have 2 important points. The UE here gets the Qos rules, and the G node B here gets Qos profiles. If I go to previous slides where I defined Qos rule and profile, you see it. Let me see where it was. It is Qos rule and profile. Here we have this one. Here you see we had Qos rules and Qos profile and Qos rule provided by 5G core to UE and Qos profile provided by 5G core to NGRAN. Here it was just a text, but here now you see it really happening in the control plane, that the UE gets Qos rules and the G node B gets Qos profiles, and we see the detail of Qos profile and the detail of Qos rules in previous chapters. You can refer to previous documents. Then in the last step, in number 5 here, when the PCF gets a Qos request from AF, the PCF generates PCC rules, and these rules are sent to SMF based on the subscription and policies. And then based on these subscription and policies, SMF generates rules and then sends them to UPF, and UPF enables the classification based on these rules, and UPF performs the bandwidth information and marking of user plane traffic. So overall, we have request from UE to application function or NAS signaling to SMF, and then SMF will cooperate with PCF and UDM to get the QoS parameters and then sends them to the G node B, and UE and also PCF sends some parameters to SMF to send them to UPF, and UPF applies them to the flows and IP traffic. This is the control plane signaling for QoS flow. Now we see the control plane signaling. Let's see the user plane signaling here. User plane QoS flow mapping in downlink direction. In next slide, we will see in uplink direction. Here, before we see the definitions, let's see what do we have. Here we have a UE, the access node or the G node B, and the UPF. Okay, so here we have the user plane specific nodes or entities. In previous slide, we just show SMF, UPF, PCF, and application function in control plane. Here we have them in user plane, UPF in user plane. We have some packet detection rules to classify packets for QoS flow marking and other actions in UPF. It is related to the TFT templates and service data flow templates and filters that we have seen earlier. We have Qos rules defined in the Qos flows. Okay, here we have the Qos flows, and we have Qos rules on them. And we have some data packets from applications in the uplink direction and in the downlink direction. And here between access node and UE, we have data radio bearers. And these data radio bearers have some resources that we can allocate to different flows. Let's see what happens in the downlink. At first, UPF maps user plane traffic to QoS flows based on the PDRs, packet detection rules. Then UPF performs session AMBR enforcement, and as we see in previous slide, session AMBR is stored in UDM, and SMF gets it and sends it to UPF to apply it on the IP flows. Also, UPF performs counting of packets for charging. So here UPF counts the packets for charging and for charging the user. In the third step, UPF performs transport level packet marking provided by SMF. In previous slide, we see that marking policies are provided by SMF, and here UPF performs the transport level packet marking in downlink on a per QoS flow basis. On each QoS flow, we have the marking. Then in step 4, UPF transmits the packet data units of this PDU session in a single tunnel between 5G core and RAN. It's important. In a single tunnel, we cannot have several tunnels for one PDU. Okay, we have one single tunnel for PDU between 5G and RAN, and we will see this in examples in next slides. The UPF includes the QFI in the encapsulation header. We see this part in a call procedure where we see the reflective QoS, that the QFI and RQA reflective QoS attribute were added to the encapsulation header on the entry interface. And here we see it again. The UPF includes the QFI in the encapsulation header. And now you can guessed that if the reflective Qos is enabled, here the RQA reflective Qos attribute is also can be added. In the last step, RAN maps PDUs from Qos flows to access specific resources based on the QFI and Qos profile. So now you see it again. We have two-time mapping in 5G. In 4G, it was one-time mapping. Once between UPF and access node and once by access node on the air interface to allocate resources. Let's go and see what happens in the uplink direction. Here we have the same image, but we check it from left to right for uplink. We have UE, Gnode B, UPF, packet detection rules, Qos flows, and Qos rules. At the first step, the UE uses the stored Qos rules to determine mapping between uplink user plane traffic and Qos flows. And also, UE can get these stored Qos rules if the reflective Qos, for example, is enabled and UE derived the Qos rules in the downlink direction and now can apply them in the uplink direction. In the second step, RAN transmits PDUs over entry tunnel towards UPF. And when passing an uplink packet from RAN to core node, the RAN includes the QFI value. And this value is added to the encapsulation header of the uplink PDU on the entry tunnel. In the third step, RAN performs transport level packet marking in uplink on a per Qos flow basis with the transport level packet marking value. And this transport level packet marking value is the 5QI, the priority level, and ARP. In the fourth step, the UPF verifies whether the QFIs in the uplink PDUs are aligned with the Qos rules provided to the UE. So here UPF checks whether these rules are available or not. And at the last step, UPF and UE perform session AMBR enforcement, and the UPF performs countings of packets for charging. So UPF do the counting of packets both in downlink and uplink direction. You see that uplink and downlink traffic flow is quite the same and have so many similarities. This was the end of chapter 6, and chapter 7 is the last chapter. And here we have the SDAP layer, NB-IoT Qos considerations in 5G, Qos fuzz, slicing difference, and QoE term, and also 2 examples in 6 slides, but I also add 1 extra slide, so it will be 7 slides. And it's about the required upgrades for non-standalone deployment of 5G on the EPC core of LTE. For example, maybe we need to upgrade PCRF, maybe we need to add some rules to the HSS and other nodes. We will see that slide. Here we see the SDAP layer. It's a new layer in 5G. In the UE, Gnode B, UPF, data network, and the interfaces between them, N6, N3, and NR-UU interface. Here we have the data radio bearer. Now you see in the UE and Gnode B in the user plane is just user plane specific. In control plane, we don't have a step layer. We have physical MAC layer, RLC, PDCP, and the new layer, SDAP layer. This SDAP layer is specified in 3GPP technical specification 3.7.324. It's so hard to write using the mouse. Sorry for my handwriting. The SDAP layer is specified in this technical specification by 3GPP. Let me check the laser point again. This SDAP layer have several responsibilities, and the first one is Qos flow handling. And in this Qos flow handling on the 5G area interface, SDAP will map a specific Qos flow within a PDU session to a data radio bearer. Okay, you see the flow in chapter, I think chapter 2. Let me show you here. You see here SDAP maps a PDU session to a data radio bearer, and it was a part of two-time mapping in 5G, one by UPF and one by G-Node B on the SDAP layer between a PDU session and data radio bearer. This SDAP layer also helps to support reflective QoS. So if we have reflective QoS, SDAP layer should be enabled and be added to the stack on top of the PDCP layer. This packet marking here ensures that the packet receives the correct forwarding treatment when it moves in the 5G system. Now let's see an example on Qos mapping. Example 1, Qos flow to DRB mapping. We have some best effort traffic here, WhatsApp video, Skype video, and YouTube stream in the internet video, and also Netflix stream in Netflix video, and voice and video in IMS video. In legacy network, the DRBs and S1 GTPU and S5U tunnel has one-to-one mapping, but here in 5G core we have just flows, and the UPF is responsible to transport the data between the G-Node B and core. Here notice that the DRB may transport more than one Qos flows on the air interface and can have one-to-many relationship with the GTPU tunnel on entry interface to UPF. Here this DRB have one Qos flow, but this DRB have two Qos flows. And also remember that these PDUs must be mapped to only one GTPU tunnel on entry interface. We cannot, for example, send best effort and WhatsApp video on one entry tunnel and Skype video and YouTube on another. Each of these PDUs have an associated entry GTPU tunnel. And here we have the QFI insertion by UPF, and we see this in the control plane signaling in previous slides. And the DRB mapping is down here by G-Node B by a SDAP layer. And also we have a SDAP layer in the UE and also the packet filters to uh, change the data radio bearers and flows to the IP flows. We have this example in more detail in next example. Here, the top of this image is previous example with more details, and in the bottom we have uplink direction. Now let's start with the upper part in downlink. Here you see we have 5 IP flows, and these are mapped to 3 flows with QFI1, QFI2, and QFI3, and then sent by the UPF over NGU tunnel on the N3 interface. This part is same as previous example. And then the NG and the G node B, the access node, have the Qos profile of these QFIs, and as you know, this G node we received them during the PDU establishment. You see it in previous slides in the control plane signaling. If I show you here it gets in the step 4 from SMF 5G access node gets Qos profiles. So here in this example, G node B knows how to map these QFIs to data radio bearers. And here QFI5 is mapped to DRB1, and QFI2 and 3 are mapped to DRB2 data radio bearer 2. And here, if we have more than one flow mapped to a DRB, we need the SDAP layer for multiplexing. But for QFI5, because there is no multiplexing and there is a one-to-one relation, there's no need for a SDAP layer. And here also note that if reflective QoS is enabled here for QFI5, then again a SDAP layer is required. So we need a SDAP in two cases. One is when we need multiplexing, or as we see in previous slide, for SDAP for mapping, and if reflective QoS is enabled in case of just one flow. And this SDAP layer, as we see in previous slides, is added on top of the PDCP layer, and this leads to an overhead add to the packets. So we will have overhead on the packets. Then these data radio bearers are received by the UE, and UE drives and saves and keeps the QFI to DRB mapping rules. So maybe it wants to use them in the uplink direction. And then the packets are forwarded internally to the application sockets, to the corresponding application sockets, whether maybe it's for Netflix, it's for YouTube, or other applications. Then in the uplink direction, here, the UE's application layer, the UE runs some applications and it generates some data packets. And then at first will be compared with a list of packet filter sets in the UE. And these packet filter sets are checked in precedence order. And when a match is found, the data packet is assigned a QFI. So this is the way that UE attaches QFIs to flows. Then this QFI is sent with access stratum. We know that this part is NAS, this part is AS access stratum, to a SDAP layer which performs a QFI to DRB mapping. Here we will have QFI to DRB mapping, and it's AS. Here you see again that QFI5 is sent using one DRB, same as download, and QFI2 and 3 are sent using DRB2 and they are multiplexed on DRB2. And here you see that SDAP header is added on DRB2 for QFI2 and 3, but for QFI5 we don't have SDAP header. It's not available. In case of one flow, we don't need it. And then they go on the entry interface NGU tunnel, and this is the uplink direction. And UPF restores the IP flows, and now the UPF knows all the tables and QFIs. Let's go to the next slide. Here we have the concept of QoS flows and network slices. I saw a lot of engineers that think that with defining some special latencies and guaranteeing some special bit rates, we can have a slice. And the QoS and a slice are same, but it's not the case. Here you see that we have a slice 1 from UE to 5G core, and it goes through the G node B and backhaul, and a slice 2, it again goes through backhaul to 5G core, and it's an end-to-end slice. And in each slice we can have several QoS flows. You see here in a slice number, in the yellow slice we have QoS flow A and QoS flow B. Maybe this is for eMBB use case, enhanced mobile broadband use case, and we have two different QoS flows in it. So it's one slice with two or even more flows. And in the second slice, which is maybe for ultra reliable and low latency use case, or maybe is for MMTC use case for IoT, we have another flow in it. So QoS flows and network slices are different terms and have different meanings. In this slide, I just want to make this clear. Here in this slide, I want to speak about the new term QoE, quality of experience. Maybe you heard it instead of the QoS, quality of service. Let's see what are the QoE attributes and how are they related to QoS. At first here, see this cylinder. You see the resource type, GBR, non-GBR, packet delay, budget, packet error rate, priority, timing average for GBR, bearer, and uplink, reflective QoS. These are all QoS indicators of 5G. And here we have also QCI and 5QI. These are the indicators that we use to make the framework to provide QoS in 5G, and now we want to use them to see how we can provide QoE, quality of experience, to the user. Here you see different services: video, voice, virtual reality, and V2X. And each of these services give the user a kind of quality of experience, and this quality of experience needs some requirements. For example, virtual reality have delay. It's a delay critical service. You can see here is URLLC. It has a specific codecs, resolution, and the V2X to connect cars to network. We need to have limited end-to-end latency and reliability, and to provide these factors we need to configure the indicators, or we need to pick the indicators to support these attributes. And this is how quality of experience is connected to quality of service. If we don't choose proper quality of service configurations and values, we cannot provide a good quality of experience to user in different services. And here you see each service have different requirements. Now, in this slide, we have a little definitions for NB-IoT. Actually, these are exceptions. The NB-IoT QoS is actually the same, and we have seen a lot of definitions in previous slides. But here we have just some exceptions in case of NB-IoT, and you can check them in this technical specification. Here you see that in NB-IoT, reflective QoS is not supported. So for NB-IoT, we don't have reflective QoS. And for NB-IoT, there is a one-to-one mapping between the QoS flow and corresponding QoS flow corresponding to the default QoS of a PDU session and a data radio bearer. You saw that we can have we can map two QoS flows to one data radio bearer in normal services, but in NB-IoT, it can be just one-to-one mapping between flow in a PDU session and a data radio bearer. The next one is the default QoS rule shall be the only QoS rule of a PDU session for a UE connected to 5G core via NB-IoT. So for NB-IoT, we just have the default QoS rule. There is only one QoS flow corresponding to the default QoS rule per PDU session. So we have just one QoS flow per PDU session. We cannot have two flows in one PDU session. We can't have two flows in one PDU session. The next one is a maximum of 2 data radio bearers are supported over NB-IoT. So here we have one-to-one mapping between data radio bearer and PDU, and maximum of data radio bearers are 2. And because it's one-to-one mapping, so maximum PDU sessions are also 2. So therefore, at most 2 PDU sessions can have active user plane resources at the same time. These are the changes of NB-IoT in 5G for QoS. This is the last slide, and then we will have conclusion. And at first, when I was making the slides for this course, I didn't include this slide, but later I added it. You see here, these are the update requirements for EPC to EPC Plus in 5G option 3X. You need in option 3X in non-standalone. The 4G is the anchor point to connect UE to 4G core, and we have the NG-RAN for user plane data. And our core is the EPC 4G core. But we need to do some upgrades in order to connect the G node, be the 5G node, to core. You see here the required updates, but here we need the ones that are related to QoS. You see that in MME, we need to support high bandwidth with extended QoS. These are the updates and changes we need to make in MME. The others are not related to QoS. You can read them. DNS doesn't need any upgrade. It's just a change, and it's not related to QoS. Again, in serving gateway and packet gateway, we need this extended QoS capability. In OCS, we have again extended QoS field portability, and also CDR needs to support high bandwidths. In HSS, you see that here we have AMBR maximum guaranteed bandwidths. Okay, we need to change it. and extend maximum request bandwidth in uplink and downlink direction. And also in PCRF and UQS extended bandwidths need to be added on GX interface. And also the other values for AMBR, APN AMBR, GBR. And if you want to add run a non-standalone network, you should upgrade your EPC to EPC Plus using these items, and it's recommended in 5G implementation guidelines by GSMA. Now we go to the conclusion. With one slide in previous chapter we had examples, SDAP, NB-IoT, Qos fuzzy slicing, and QoE in 6 slides, and I added one slide. Now it's 7 slides. The last slide was the recommendations for upgrade from EPC to EPC Plus. Conclusion is our last slide. We had a lot of content, but here are just some notes that we can see how things changed in 5G and what important things we have. First one is QoS implementation should focus on solving a specific business and customer requirements instead of just pushing network QoS as a technological change. Okay, this was because we need to get money from business owners and we need to solve their problems. Implementing QoS as a technology is not enough. The second one is the concept of QoS in 4G LTE is based on bearers, while in 5G is based on flows. Now you know it. It's clear. 5G QoS flow is characterized by a Qos profile provided by 5G core to NG-RAN and Qos rules provided by 5G core to the UE. So these flows are characterized by Qos profiles and Qos rules. And these Qos profiles have so many Qos indicators, we talk about them, and also these Qos rules. 3GPP standards align QCI values of 4G and QFI values of 5G to facilitate 4G 5G handover. You see this in tables. We see the 5 QI values in QFI tables and the QCI values. Okay. For example, for voice traffic, we had 1 in QCI and QFI. It was again 1. Service Data Adaptation Protocol SDAP layer is responsible for QoS mapping and also marking in 5G radio and also for reflective QoS. It does not exist in 4G. The SMF function in 5G network has pivotal role for QoS enforcement, and it interacts with the UPFs, the RAN and UE to achieve the appropriate treatment of the user plane traffic. These were just some notes, not to conclude, but to summarize the course. And finally, thank you to looking at this course. I hope that you liked it and I hope that you learned something useful and you can use it to implement QoS in your network. And again, in case of any question, you can contact me on my LinkedIn account or using my other contact details on my profile webpage plalinejad.ir. So this is the end of this course, and thank you for watching me. Bye.